But in this example, let's see, a 2 minus a 1. 1, okay. So when we put those x's together, we get a plain x. Bring down the rest. So sure, it's okay to simplify first. Nothing changed from the stuff I've taught you before in chapter 1 up until now. You can still combine like terms. Notice something for me though, guys. When you put the x's together, they're like on the same side, aren't they? They're on the same team, kind of. If they had been on different sides of that equal sign, we would have to think harder. I'll show you stuff like that later. But just for now, notice they are on the same side, so I can just combine them easily. I can simplify them like I wanted to. Now remember, my objective is to get x alone. So to do that, I want to get rid of what? The 3. Okay, that's what's attached to the x. And how's it attached again? With a plus, so the opposite of plus is minus. Same thing both sides. That gives me a 0 on this side. X is equal to 6 minus 3 is 3. And of course we could test that. You can test it at any step, because you know that as long as you're not breaking any rules, as long as you're just simplifying, going from that first step down, you didn't change the relationship, did you? You could plug that 3 into any step. See, watch. 2 times 3 minus 3 plus 3 equals 6. That gives me a 6. Oh, minus 3 plus 3 kind of gives me nothing, doesn't it? Could I cancel that? Nothing. 6 equals 6. Okay. Or you could have checked the next step. As long as you didn't break any rules, you can actually check any time throughout your equation. To be honest with you, I recommend that if you're going to check your work, I recommend you check the very original. That way, if you made a mistake, you'll see it quicker. But yes, on both of these, we get that it works. Because they are the same equation, just written differently. We just simplified the top one. Are we okay? Okay, let's see. Let's look at equations with multiply. We'll start putting the steps together probably tomorrow night. So I know, you may have seen harder stuff before. Don't get yourself too excited. We're just practicing the fundamentals tonight. Let's say, for example, that you had 2 times x is equal to 6. We said a second ago the opposite of multiply is divide, okay? So what's my objective again? When I see an equation like this where I have an x, what am I trying to get by itself? X. So I want to kill what? 2. I want to cancel with 2. How's it attached to x? With a multiply. The opposite of multiply is divide. Because remember, 2 divided by 2 is a 1. So this cancels. What I write on one side, I had better write on the other side. So x is equal to 3. Now what we're using is called the property of multiplication, or multiplication property of equations. Same thing as before. Multiply or divide on one side. As long as you do it to the other, your equal stays true. You didn't break any rules. You're keeping everything happy. That's what we did here. Let's look at another one. Let's see if I can give you one that's more tricky. Oh, I've got one. Negative x equals 5. Is there work to do, or is this already the answer? Is x already by itself, or is there something attached to it? Yeah, there's something attached. You don't stop your problem when you have a negative sign in front. That's different, isn't it? What's in front of x? Invisible. If I wanted to be explicit and show it, sure. I could show -1 times x if it made me feel better, right? Let me show it just this time. I don't expect that you guys have to show it though in the future. But if I wanted to, remember, this is the same as -1 multiplied by x equals 5. Ah, this looks more familiar to the one we just did. I don't want that -1 there, do I? How do I get rid of it? It's attached by multiply, so do what? Divide. You look at how it's attached, guys. If it's attached by times, the opposite of times is divide. So x is equal to what? -5. You can also just think of it as -x equals 5, divide by negative, divide by negative. I don't care how you look at it. If you want to abbreviate it in your mind, that's fine with me. That was horrible, I know, but you can just remember that the negative is just going to change the sign of everything on the other side. Something I think I should say that I haven't made very clear yet. I've told you that so far, if you add to one side, you add to the other side, right? You multiply to one side, you multiply to the other, divide to one, divide to the other. Technically, guys, what you are doing is you're doing that to everything on the other side. So when you are dividing by a -1 on the left, everything on the right was divided by a -1. Now, these problems are super easy. There's only one number on the right. If there had been more than one number, everything would have just gotten divided. Does that make sense? Okay. So remember, it's actually happening to the entire side every time you do this. And that will matter to you later on in math. Let's say you had a fraction. There's actually two ways to handle those. So I'll use this one. Still, it's attached by multiply, right? I mean, I could have written it as 3/4 times x equals 9 if I wanted to, right? When I want to kill something attached by multiply, I'm trying to think of opposites, right? Which the idea is if I have a fraction, when you divide by fractions, you're really flipping them, right? So what I can do here to kill the 3/4 in one step if I want is I can times by what? 4/3. Remember that'll cancel? So times by 4/3 on the left, you must also do it on the right. So you get that x is equal to, what's 9 times 4? 36. Over 3. Sounds like x is 12. Is that right? If this bugs you, there's another way you can look at it. Do you guys want me to show you how you can also look at it? Just in case. Or you could look at it this way. This is the way that I used to look at it when I was in algebra, because for some reason fractions just freaked me out. I didn't want to have anything to do with them. So what I always did is I would say, okay, my objective is to get x by itself. I'm going to start killing off the pieces touching it. Now, just so you know, FYI, your strategy in the future is always going to be to start with what's least attached, kind of like if you were in war, right? If you were in a battle, you start with what's the loosest, and you work your way into where you want to be. Well, with this, you're trying to isolate that x. You're trying to get in there to start with what's least attached before, and then work your way into the x, killing off pieces. How's that 4 attached? Divide. Okay. Opposite of divide is multiply. So I could have said times by 4 times by 4. Now, guys, it's legit to do this more than one way. As long as I'm doing the same operation to everything on each side, I'm keeping the equal sign true. So my strategies can be different. I know that, of course, this cancels. And then I can say, now I have 3x is equal to, what's 9 times 4? 36. I still want x by itself. What do I want to get rid of? 3. How's 3 attached? Okay, opposite of multiply is, okay, so divide by 3, same thing both sides. Once again, you get x is equal to 12. It's whatever you're more comfortable with. I mean, notice this way on the right, it's true that it takes more steps. The reason I used to like it when I was in algebra is because I just hated fractions. If you're okay with fractions, just remember to flip the thing. When it's attached to x, flip it and times it. That will always kill it. Or you can do it in 2 steps, whatever. So let me show you one more thing, and then we'll transition a little bit and come back to more equation stuff next class. One more example. How about this? Except I'm going to try to write it neater. X divided by, no, how about negative 12? Is equal to 4. That negative could have been anywhere, couldn't it? It could have been up on top, out in front. Does it make a difference? Not really. If you see it as being on top, you just divide by negative at the end, right? But you could write it on the bottom like this always. Just don't write more than 1. We have 1 here. Keep that 1. Just stick it somewhere. We don't care. To get x by itself, what do we want to kill? How's it attached? Okay. So the opposite of divide is multiply. Multiply by 12. Multiply by 12. Negative 12, actually. This cancels. X is equal to, you got it, negative 48. Nice. Not so bad, huh? Let's try one more that has more than 1 step. Just for kicks. I know I said one more example and now I'm making it another. But you guys could handle this, couldn't you? I'll give you a second to write. Remember, I'm going to be putting these online as a PDF from now on in your Blackboard account. I'll try to make a button that makes it really easy to get to. Okay, what's the first thing I should do? Combine, sure. Why would you try to isolate x if it's all over the place? Let's put the thing together. Let's combine our like terms. 4 minus 8 gives me, okay, negative 4. Keep that x on there, equals 16. So now we have a simpler version. That's why we used chapter 1 time to learn how to simplify, because of now. To get x by itself, what shall I do? You got it. Same thing both sides. And x is equal to what? Sure, you could check it. Just plug negative 4 in everywhere in the original, and you'll get a true statement. The next thing that we look at here is just exploring more types of equations. So this is kind of a basic intro to equations where you're going to solve for a variable. There's other equations that are kind of more formula-like.